Hi, I'm JD with Revolution Machine Tools. Today I want to talk to you about some of the uses and features of our TGB series machines. And today I'm going to go over some terminology that might be beneficial for you to know to work on your TGB. So, first off, we're going to talk about thousandths and how to pronounce them. This is something very commonly used in the machining world. And so right here I have an example that I wanted to go over. So we would read this 1 inch, 134 thousandths, and 7 tenths. So typically we won't be working with tenths as that is an extremely small measurement. But it's important to have a standardized way of saying this, because if we don't, then there can be miscommunications amongst operators or engineers, and we could have parts cut very incorrectly. Second of all, I wanted to talk about concentricity and ovality. So what these are meaning is concentricity is when two objects are sharing the same center point. This is going to be particularly applicable on your TGB when we're talking about the material that you're holding being concentric to the actual spindle. Now this is important because if they are not concentric, then when you start to go cutting, you're going to be cutting really heavy on one side of your material and very light on the other. Now, ovality is a deviation from cylindricity. Now, this is important because if we are clamping onto our part in our TGB, there's a potential that the clamp pressure could be high enough that it squishes that material into an oval. And so obviously, then when it becomes unrestrained, the material will spring back and it will no longer fit or match our print. So just make sure that when you're setting up and doing things, you're looking for ovality as well as keeping an eye on your clamping pressure. Next, a CNC. So RTGB and many other machines are considered CNC machines, which just simply means computer numerically controlled. All right, so this does not necessarily just apply to TGB or mills or lathes or anything like that. It's just a nomenclature of saying this machine is automatically doing functions based off of its computer. Next, the controller. So it's very simple. It's just the big box that the operator stands in front of to interact with the machine, putting in offsets and codes and everything they need to interface with that and tell the machine what to do. Next are axes. So axes are a plane of which the machine can move on. All right, so this is just basically our movements of direction. On our TGBs, we have two different axes. One is called the x-axis, and the other is called the z-axis. So I'm sure most people are familiar from grade school with something that looks a little bit like this, having x positive, x negative, y positive in a grid system. This is very similar to our axes, but instead of being on a 2D flat surface, it's now going to be in a three-dimensional movement, right? So my example over here is this is our spindle. The lines, the solid lines intersecting the spindle are the X movement. It's the actual plate that moves in X. So it's not always right and left for the X, which side is positive and which side is negative, because it determines where the spindle is oriented, right? If it's oriented upside down, from what we typically think, then our X positive and X negative would be inversed. But to give you an idea, my X is going to be moving along this plane of movement, while my Z is going to be moving in this plane of movement, coming towards and away from us. So our Z positive is always going to be away from the material, and our Z negative is always going to be towards the material. Now, Another thing I want to talk about is offsets. So offsets are very important, and knowing which offset you're working with is extremely important and can potentially save you from crashing the machine. So the first type that we have is a work offset. This is also commonly referred to as a G54. This is basically where we are telling the machine that our material exists in space. The machine knows where it exists, but it doesn't know where anything else is. So we are simply defining it where it exists, so that way when we tell it to go to, say, Z0, which would be the face of the part, it knows where that is. Now, the next type, is a geometry offset. So this is defining where our tools are, right? Again, the machine knows where it exists, but if I have a tool way on the outside of my spindle and another one that's really close to the center of my spindle, the machine doesn't know where those are until I touch off those offsets and tell the machine where they exist in space, and then it can make the appropriate cuts. This will all be covered in offsets in another video. Next is wear. So wear offsets are basically how you are fine-tune adjusting or compensating for the wear of your tool before its life is completely out. So when you first start cutting on your parts, they may be coming out perfect, exactly nominal where you want them. However, after so many parts have been ran, you could potentially see that your parts start to grow a little bit larger, and that's just because your insert is slowly wearing out. That doesn't necessarily mean that it's ruined or completely done quite yet. So we can make wear offsets to adjust for that and compensate for that. But it is important to note the difference between wear and geometry, because they are both on our tool, right? They are both a tool offset. However, the geometry defines where it exists, and wear defines how worn down it is. So if you go and change your insert later, but you altered your geometry to compensate for that lack, of material cutting, then when you put your new insert in, it's going to cut way too heavy, and you might not remember what numbers you altered to what numbers. So that's why we have wear offsets. Next, we're going to be talking about what's a program, right? So a program it's just a script written in what's called G&M code. G&M code is what the controller reads and allows it to know what appropriate movements it needs to make. The programs are not one that are really feasibly done at the controller. It is typically something that you have to bring from an outside CAD CAM software and put into your controller and then save it. Next is cutting. There's a little bit of misunderstanding on what cutting actually is. Cutting is everything. Everything that removes material away from the original part. This can be threading, turning, grooving, broaching, the list goes on. But the primary ones that we work with on the TGB are turning, which is where we are turning down the material to a certain size, whether that be an outside dimension or an inside dimension, just getting it to that spec. Threading is fairly obvious. We're putting threads onto that new OD or ID. And grooving is when we're cutting grooves into it, whether it's like a Victol groove or something like that. These are all forms of cutting, so we need to specify what form of cutting we're doing, otherwise there could be some misunderstanding. Inserts and indexing, this is a pretty obvious one, but the inserts are the actual implement that cuts the tool. Most everything that we use in our TGBs are carbide. They are replaceable, so the tool holder holding onto the tool is supposed to be a permanent fixture that never gets replaced. unless we crash it, but the insert is removable and replaceable. And indexing that insert looks a little bit different for each and every insert, depending on the type, but essentially what that means is rotating it or flipping it over or something like that to get it to a new cutting edge. Commonly, like threading inserts typically have about 3 different cutting edges per insert, whereas our CMG turning inserts typically have about 4 edges that you can utilize. Now, the next two definitions, hard keys and soft keys, are extremely tied together. This is when we're looking on our actual controller. In the next videos, when you see the controller, it will make a little bit more sense because I'm clearly not an artist. However, hard keys are basically just keys that have a dedicated function. It is usually, you can usually tell by looking at it, because if it has something written on the physical button that you press, then that is probably a hard key. It can't do any other function. It is simply to input, or it is the number 0, or whatever the example may be. Soft keys are keys that sometimes have no function or changing functions depending on what screen we're looking in. So if we're looking in our offset screen versus our program screen, all of my options for the buttons along the bottom are going to be different from one another. So they have constantly changing meanings. These are all the terms you really need to know to hit the ground running with our TGBs. Here I will show you the controller manipulation that I am using when I am physically touching off a tool. I am turning my spindle speed down to the lowest setting and turning the machine in the appropriate direction. In this case, I need to spin it clockwise to successfully work with my tools. I will then speed this up to the appropriate cutting speed, and I will jog my machine in close using this button, and once I get close enough, I will use the handle jog to move in and out as necessary. Alright, so in this video, I'm going to be showing you how we're going to touch up our tool offsets and our G54 offset, or our work offset. Now, first thing, before we actually start cutting with our tool, ensure that you have properly adjusted your vices to be concentric with the spindle. Otherwise, we're going to be digging in really deep on one side and really light on the other side, potentially causing damage to your inserts or even breaking them. So that is very first. Now, what I'm going to do is I'm simply going to jog this up close-ish, and then I'll do some fine-tune adjustments before I actually turn on the spindle. So while in jog mode, I'm going to bring my Z negative until I get reasonably close. Then I'm going to switch over to my handle mode and use my jog box to get in closer. So right now I am working with what's going to be my tool 1, and it is on the positive X coordinate, which means for me to go deeper into the part, it's a negative movement in X, whereas if my tool was on my positive X, then it would be a positive X value to go deeper into my part. Now, also remember, the spindle rotates, and so don't think of positive and negative as like right and left, so to speak. You just have to know tool 1 is negative and tool 2 is positive to go deeper. But I'm just going to kind of eyeball this close. So now my insert is going to make contact with my part if I go in deep with the X. And I want to start it off with just about a finger's width away, about that from my part. The reason for this is, one, if my material is not perfect, it might have low and high spots and stuff like that. So when I go to start cutting it, if I get it real close to this edge, if this is the low spot and say over here is the high spot, then it's going to dig really hard, and we're going to have a similar issue as if the vise isn't concentric, right? Now, my second reason, though, is because I want to take this time before I start anything, just verify everything is where it needs to be. My material's clamped, my space is right, all my covers are closed, and I'm wearing the appropriate PPE before continuing. But from here, I would just turn on my spindle in the correct direction for cutting, and just slowly start to feed in X on my jog box until we start to hear it just make contact, very lightly. We don't want it to sound too interrupted. That means that our vise isn't centered, but it should be a nice, like, smooth sounding cut that doesn't sound too interrupted. All right, so now my spindle's off. I'm going to open up my cover, and that I would then go over to my controller, and I would type in the necessary information to touch off for the X of that tool. Now, I'm going to treat this as my tool 1, and with my tool 1, I'm going to set my G54, so that's what I'm going to do next. That means, though, that I'm not going to touch my tool off in Z. For any other tool that is not the reference tool, you would touch off in Z. But what that would look like is I'm going to come out a little bit, and I'm basically just going to go in until it looks really, really, really close, that my cutting edge is lined up with my material. And for most things, like threaders and stuff like that, that's going to be good enough. But other things, if you're able to, I would suggest going and actually trying to cut just a little bit of the face of our material in order to set that Z value. But now, instead, I'm going to set my G54. So all I'm going to do here is basically what I just told you, except I'm going to be putting more surface of that carbide insert on that material. Now again, I want to stay a little bit away from that face because this is not necessarily squared to the machine yet. So if I start too close, it might come over here and hit really, really hard. So I'm just going to make sure that I'm amply away, about a finger or so. And then I'm just going to do the same thing. I'm going to close up the guards, but this time, instead of coming in X, I'm going to come in Z until it barely starts to touch. And then I'm going to come out in X without moving my Z, and I'll set my G54 that way. Now I will go over how to set our workplace offset that being our G54, as well as our tool geometry offsets, and adjust our wear offsets as needed. First thing I'm going to do is go into edit mode. I will then come over here and select the offset hard key. I will then highlight the axes and the tool number that I am working with. So I am currently working with tool 1 in the X axis. I will then type X, as that's the axis I'm working in, and then whatever the outer diameter of your part is. In this case, I'm going to say it's 4.5 inches. I will then come down here to a soft key and select measure. Now, currently, tool 1 is in my positive X axis, and tool 2 is in my negative X axis. So we will repeat the same process with a minor variation. We will type X, but now this number needs to be a negative 4.5 inches. And then again, selecting measure. If you do this backwards or incorrectly, your machine will try to move in a way that it cannot, and it will alarm out, giving you an over travel alarm. Now, if I wanted to adjust my wear, I simply go over to wear, and then, as necessary, can put in my offsets. So, let's say I needed a negative 10 thousandths offset. Now I can hit input and it will populate there. However, it is a better habit to type in the number and then select plus input. This will take the current value in the highlighted box and the number typed out, and it will verify that this is the number you are striving. Then hit execute, and it will now update to 30 thousandths instead of the 20 thousandths that I had entered. I could, again, just simply hit input either here or here, but it will eliminate the previous data in there and only input whatever is currently in your active box. Then, to get to our workplace offset, I'm going to press offset until I see the soft key for work. I will then go down and highlight my Z axis of my G54. Make sure that you are not in any of the other boxes, as this could lead to an issue. I will then type out Z0 measure, and this is for my Z. It is important to note, however, that you need to have a tool selected that has a Z value of 0. What this means is if I go back to my offsets here, go back into geometry, and look at all my Z values. Currently they are all set at 0. Typically, our tool 2 will have a offset in it. So if I had this as my active highlighted tool, notice when I go back to my work offset, first we need to select the tool that we are trying to use. So I'm going to soft key until I can see this program. Under the program, I will key over till I see program. I will then go into MDI, or manual direct input. I will then type out tool and then whatever number I'm using. So in this case, I would suggest using tool 1, and it is typed out as tool 0101. This is the same format for any other tool, but replacing the 1 with the appropriate number. I then hit the end of block or EOB, and then press input. I will then hit cycle start, and if I come to my custom graphics page, you will note up here it tells me that I'm working with tool 101. However, if I go back to my program and say I was working with tool 2, it will still reflect up here, but if you do not check this and go to set your G54 or any of your tool geometry offsets with a selected tool that has a wear offset, or a Z offset in the geometry, then if I go back to my work offsets, should be at 0, because when I touched it off with tool 1, we are referenced to Z0, and I had 0 in my tool 1. However, now I'm highlighted, or I've selected my tool 2, so if I type Z0, don't need that decimal, Z0 measure, it then gives me a number that is incorrect. If you are not using a tool that has a Z value of 0 in its geometry and you measure your G54 or any other tool, it will cause a crash. Because now the machine believes that the part exists in a different space than it really does. So be very, very certain that whenever you touch off anything, we are verifying under custom graphics and the top right corner that we are using the appropriate tool number. In this video, we are going to go over how to load a program from a USB into your controller and how to select between different programs already in your controller. First thing we're going to do is open up our USB port here. We will then insert our USB. Then you will go to Program, select Folder. Then we will go to Operation, Device Change, USB. This will then have a list of all the programs currently on your USB. Whether you are re-downloading an old program that got tampered with or loading a new program. We will then highlight the desired program and arrow to the right until we see F input. Select that. I will then select F get, F set, which then should populate my F line, F get P set, which should populate my P line. And then I will select execute. First thing, we can see and verify that this number at the very top of my screen did change to match the program number. So that tells me I successfully loaded a program. But I'm still in my USB memory and I need to go back to my controller memory. So I will arrow over until I see device change. Then again, I will select, well, this time I will select CNC memory. Now I have my two programs that are loaded on here. If I was desiring to run this program, I would simply, once you go into operation, just select main program. The @ symbol should indicate which program is currently selected, as well as at the top of the screen.